Alright, so today we're continuing on in our lesson about trigonometry, and we're going to talk about angles of elevation and depression. So what today's lesson is kind of a culmination of all of the trig stuff that we've done. This is the application of that. So these are going to be real-world contexts that we're going to be solving these problems. So our objective is we will be able to use angles of elevation and depression, so I need to know what those are, and how to use them to solve for missing measures in contextual situations. So we're going to be still solving for a missing side or a missing angle, but it's going to be in context of what it might look like in the real world. So in order to do that, the first thing is I need to understand and be able to define what an angle of elevation and depression is. I can identify key information from a given contextual situation, so I can pick out the important information, and then I can label that key information. I can draw a picture, I can set up and solve a trig equation, and then answer the question in context. So we're really going to pull from what we did yesterday in solving trig equations, only now instead of being given the triangle, I have to draw it from information. Alright, this is your exit ticket today. You're going to have 2 word problems, and you're going to have to be able to set them up and solve them in order to answer the question. Alright, so let's get some basic understanding. So an angle of elevation is the angle formed between a horizontal line, the horizon, and the line of sight to an object above the horizon. So angle of elevation is pretty straightforward. It's if I'm standing here and looking straight out, so it's the horizon, and I go up. If my eyes go up, then it's an angle of elevation between the horizontal line and whatever my line of sight is. So the angle of elevation goes up from that horizontal. Alright, so the angle of depression, which is the opposite, obviously, is the angle formed between the horizontal line and the line of sight to an object below. So if here is my horizontal line, then the line of sight below, this is the angle of depression. Now, you have to be very, very, very careful, because what's going to end up happening is with these word problems is we're going to be creating right triangles. And a lot of times what students want to do is they want to label this as the angle of depression. But that is not the angle of depression. The angle of depression always goes on the outside of the triangle because it's formed between the horizontal line and the line of sight going down. So the angle of depression would be here. And we'll talk about how I find the angle that I'm going to use. But be very, 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 very careful. You always put the angle of depression on the outside. It's from the horizontal line downward. Alright, so let's just take a second and let's look at, we have a bird flying in the air. We have a person who is looking out of a hot air balloon. We have the top of a mountain, and then we have the bottom of the mountain. So let's go ahead, and I'd like you to label each of these angles. Angle 1, angle 2, angle 3, and angle 4 are the angles of elevation or depression. And I want you to keep in mind that it's always from the horizontal is the line of sight going up or going down. So label them angle of elevation, depression. Alright, so angle 1 is an angle of depression because if I look, here's my horizontal line, and the line of sight that is being created from it is going from the horizontal downward. So that is an angle of depression. Okay, the man looking up at the bird, so here's my horizontal line, and so if I go from the horizontal to the line of sight, it is an angle of elevation. It is going up. Alright, so angle 3, from the line of the horizontal line, the line of sight is going down, so it's an angle of depression. And then when I think about angle 4, here's my horizontal, so to go to the line of sight, I go up, so it's elevation. So those are the angles in application. Looking at them, are they depression or elevation? So I want you to look at this graphic right here. I have a lighthouse, and there's a horizontal line going out from the lighthouse, and I have a boat, and there's a horizontal line going out from the lighthouse. So I want you to think about these 2 lines, these 2 horizontal lines are going to be parallel, right? Because horizontal is parallel to all horizontal lines, no matter where they are. So I want you to think about from the lighthouse, here's my horizontal, so if I go to the line of sight, it's an angle of depression. from the boat, here's my line of sight, or here's my horizontal, so if I go to the line of sight, it's an elevation. I want you to think about using our knowledge of parallel lines, and this right here, what can I conclude about the angle of depression on the outside and the angle of elevation from the bottom on the inside? What do you think I can conclude? So those angles are actually going to be congruent. So this angle of depression right here, from the horizontal above to the line of sight, and the angle of elevation here, from the horizontal below to the line of sight, are actually going to be congruent. Why do you think they're going to be congruent? What mathematical knowledge do we have about parallel lines that would make those two angles congruent? Alternate interior angles between parallel lines are always congruent. So if I think back to this horizontal line is parallel to this horizontal line, here's my transversal, I know that alternate interior angles are congruent. So that's going to help us as we move forward, because the angle of depression is always on the outside, but I know that the angle of depression is going to be the same as the angle of elevation from below. So as I work through these word problems, I'm going to use these guiding questions. So what is key information? How can I label each piece of information? What picture can I draw? What information is given? What trig function should I use? What equation can I write? And then what's the answer in context? And if you notice, these three questions we've already done. We've done those yesterday when we were solving trig equations. So now the big piece is just being able to pick out the important information and draw a picture and then answer it in context. So we're not really adding a whole lot more today. Alright, so example 1, I'm going to set up and solve for each missing piece. So an eagle is perched 40 feet up. Usually math numbers are important. In a tree, and looks down at I think that's supposed to say 35-degree angle, and spots a mouse. How far, so that's my task, is the mouse from the tree to the nearest 1/10 of a foot? Alright, so what is key information I picked up? How can I label each piece of information? So I know that 40 feet up, that's a vertical. That's a vertical distance. I know if I'm looking down, that's an angle of depression. And then how far is the mouse from the tree? I'm looking for the horizontal distance. Alright, so what picture can I draw? Alright, so I'm going to draw a tree. I'm not an artist, so we'll just go with it. I've got my bird. I can't draw, so that's my bird. He is perched 40 feet up in the tree. So I said this is a vertical distance, so I'm going to say that he's 40 feet up. Alright, he looks down, so his line of sight is looking down. So if I think about, here's the horizontal line, his line of sight is looking down. Okay, so the angle of depression is going to be 35 degrees. And he spots a mouse. So there's the mouse. How far is the mouse from the tree? So I'm looking for the horizontal distance right here. That's going to be my X. That's what I don't know. Alright, so I drew a picture. What information is given? Alright, so I see, here's my right angle. Okay, so I see my right triangle. I'm given, let's see, where's my reference angle? Well, the angle is outside. The angle of depression is outside of the drawing, so I'm not sure where it's supposed to be. So I need to remember back. I remember that these are parallel lines, so this 35 can also be labeled down here as 35 because they are alternate interior angles. Another way that you could do this is you could think of this angle right here as 90. So if this is 35, I can say 90 minus 35, and I can plug it in right here. And then I would use a different trig function to do that because my reference angle would be up here instead of right here. But that either way will work for you. I like to just remember that these are alternate interior angles. Alright, so stepping back in, here's my reference angle. What information is given? So 40 is opposite, x is adjacent. So which trig function should I use? Well, opposite and adjacent is tangent. So what equation can I write? The tangent of 35 is 40 over x. Okay, so all I did was, here's my reference angle, the tangent of that is opposite over adjacent. So now I need to say, how do I solve? So when I think about it, x is in my denominator, so I'm going to write a proportion. And I'm going to cross multiply. So I'm going to say x times the tangent of 35 is equal to 1 times 40, which is just 40. And how do I undo times the tangent of 35? I'm going to divide by the tangent of 35. So in my calculator, I'm just going to type in 40 divided by the tangent of 35, and I get x equals 57 point, it says tenth of a foot, so 1 decimal place, 1. Alright, so what is the answer in context? So I'm going to say the mouse is 57.1 feet from the tree. And yes, you do need to write that sentence. Alright, so that's how we solve these word problems. Alright, so for example 2, I'd like you to read it and I'd like you to do these first 2 questions. So go ahead and pick out the important information and label it. So what kind of trig labels would we need? Angle of elevation, angle of depression, vertical distance, horizontal distance, the hypotenuse, that would be if it's something angled or if it's tilting. So go ahead and see if you can pick out those 2 questions worth of information. Alright, so you should have picked out that the ramp is 18 feet long, and you should have labeled that either the angled line, because if you think about what a ramp does, it's the angled piece, or I just straight up called it the hypotenuse, because the angled side will always be the hypotenuse. It rises, so you should have picked out rises, and that's an angle of elevation, and then 22 degrees is actually the angle of elevation, and then the task is to find how high. So how high, that's a vertical distance, is what I'm looking for. Alright, so what picture can we draw? Alright, so I've got a moving truck, and it has a ramp that is 18 feet long, and the ramp rises. So if it's rising, I'm talking about, here's the ground, so there's my right angle. It rises at an angle of 22 degrees. So that angle right in there, that elevation, is 22 degrees because it's talking about from the horizontal, it goes up. Alright, and then the question is how high off the ground. So that's the vertical one that I'm looking for. I'm looking for this distance right here, how high off the ground. Alright, so what information is given? So when I look at this, here's my reference angle. X is going to be my side opposite, and 18 is the hypotenuse. So which trig function can I use? So which trig function uses opposite over hypotenuse? Well, that's the sine. So I'm going to say the sine of 22 equals x over 18. Alright, so x is in the numerator, so I can just straight up solve this by canceling out the time, or divided by 18. So in my calculator, I'm literally just going to type in 18 times the sine of 22, and I get 6.74. It doesn't say to round specifically, so I always go to the hundredth if it doesn't tell me. So 6.74, and I need to think, does that make sense? Could it have a 6-foot ramp? Yeah, that's about right. That seems a little bit high, but if it's 18 feet long, that gives it some room. It's probably one of those really big trucks. So the last question is, what is the answer in context? So I just need to answer that question. The ramp is 6.74 feet off the ground. Alright. Alright, so for this example, I'd like you to try to answer questions 1 through 3. So see if you can pick out the key information, and then see if you can draw a picture, okay? Alright, so this question was a little tricky, but I wanted to see if you can figure it out. So obviously we should have picked out that 32 feet from the flagpole is a person, so that's a horizontal distance. They can see the top of the pole at a 47-degree angle of elevation. So they already tell me it's an angle of elevation. So we know that the eye level, which is the horizontal line, because I needed to draw that in, is 4 feet from the ground. So this angle of elevation isn't starting until 4 feet in the air. Okay, so here's the line of sight, or here's the horizontal line of sight, and then the angle of elevation goes up to the top of the pole. So I'm looking for what is the height of the flagpole. So I'm actually looking for the whole height. But when I look at this triangle, X is only going to tell me this to the line of sight. So to my final answer, I'm going to have to add on that 4 feet because my angle of elevation only goes from here up. It's only going to talk about this triangle right here. So that 4 feet is going to have to come into play at the end. So let's see what equation we can set up, or what information is given. So here's my reference angle. All right, X is my side opposite. And I know the horizontal distance to the flagpole is 32 feet. So if it's 32 feet here, then it's going to be 32 feet here, which makes it part of my right triangle. So 32 feet is my side adjacent. So when I think about what gives me opposite over adjacent, it's going to be tangent. So the tangent of 47 is equal to X over 32. All right, so where is my variable? My variable is in the numerator, so I'm just going to undo divided by 32 by timesing by 32. So when I put 32 times the tangent of 47 in my calculator, I get that X equals 34.32 feet. And so that tells me that is this value of X. So that is the distance from my line of sight to the top of the flagpole. But my task is to find the total height of the flagpole. So I need to add on those 4 feet that I know represent from the ground to my line of sight. And that gives me 38.32. So my final question is, what is the answer in context? So in context, the flagpole is 38 feet tall, and I went ahead and rounded because it asked me to round to the nearest foot. So 38 or 39, well, 0.32 is closer to 38 feet than to 39 feet. All right, I'd like you to do example 4 and 5 all on your own and see what you get. All right, so I ended up getting that the submarine is 401.92 feet below the surface of the water. So if you got that, you can go ahead and move on. If you didn't get that, I'll explain to you right now. All right, so it says the submarine descends, so that's the angle of depression, at an angle of 15 degrees. It travels a horizontal distance, so they've already labeled it for me, of 1,500 feet. What is the depth? So the depth is the vertical. That's what I'm solving for. All right, so I drew a picture, and here's the surface of my water. And here is the submarine's path. Here's my submarine now. So it had an angle of depression because it descends. So from that horizontal, it went down 15 degrees. So my 15 degrees is on the outside. All right. And I know that the distance from where it went into the water to the distance where it is now is a horizontal distance of 1,500 feet. Okay. And then the question is, what is the depth or the vertical distance? So I drew that down and I made my right angle. So I labeled that X, okay? Well, when I looked at this triangle didn't have a reference angle, and I still had a variable outside. So when I thought about it, I know that horizontal line and horizontal line are parallel. So the angle of depression with the upper horizontal line is going to be equal to the angle of elevation with the bottom horizontal line. So I went ahead and labeled that 15 degrees. So when I looked at this from my reference angle of 15 degrees, I had the opposite and the adjacent. So when I think about opposite and adjacent, I know that's tangent. So I set up the equation. The tangent of 15 is X over 1,500. So the tangent is opposite over adjacent. And so when I look at this, my variable is in the numerator. So I multiplied by 1,500 on both sides. And I literally just typed that into my calculator. And I got 401.92. So what is the answer in context? Well, that 401.92 means that the submarine is 401.92 feet below the surface of the water. All right, so for example 5, I got that the kite is 96.59 feet above the ground. So if you got that, you can go ahead and move on. If you didn't, then I will walk you through it. All right, so the first thing is what is my key information? So while flying a kite, you get it stuck in the tree. You let out all 100 feet of string. So when I think about a kite stuck in the tree and the string is going to be that angled or slanted. So I called that the hypotenuse because I know that the slanted line is always the hypotenuse. And I know that the angle that the string makes with the ground, so if I think about the ground up to a tree, that's going to be an angle of elevation, which is 75 degrees. So my task is to find out how high. Well, how high indicates what's my vertical distance will I have to climb to retrieve the kite. All right, so then my next question is, what picture can I draw? So the picture that I drew is, here's my tree, here's my kite stuck in the tree, and then I know that the string to me at the ground is 100 feet because I've let out all 100 feet of that. So the hypotenuse is going to be 100 feet. I know that the angle that the string makes with the ground is 75 degrees. So that's my angle of elevation, because I said with the ground going up to the string, that's going up, so it's elevation. And then how high, that's my variable. So I want to know, what is this distance right here? So I went ahead and drew my right triangle. Here's my angle because the tree makes a right angle with the ground. And I looked at what's given. So I'm given opposite and hypotenuse from my reference angle. So which trig function uses opposite and hypotenuse? Well, the sine does. So I wrote the sine of 75 is the opposite over the hypotenuse, or x over 100. So when I look at that, my variable's in the numerator. So how do I undo divided by 100? I multiply both sides by 100. So I literally typed this into my calculator, and I got x is 96.59. Alright, so when I looked at this, I noticed that it says an angle of depression. Well, I know that an angle of depression is always from a horizontal downward. So it's going to be that angle that forms with the horizontal. So when I look at this picture, I notice that here's the horizontal, here's the path of the ball, and I notice that the 20 degrees is on the inside. Well, the angle of depression is always from a horizontal line. So if I look at this angle of depression that they've drawn in, there's no horizontal line here. I have my slanted line and I have a vertical line. So I redrew the 20 degrees and I said it should be on the outside because it's always from a horizontal line. Just like an angle of elevation is always from a horizontal. So it shouldn't be there, it should be there. Alright, so that is the end of your notes right now. So if you are ready to try your prove it, you may, or you can move on to the activity.